All right, so yeah, as the boss mentioned, space is certainly an emerging field and something that's going to become increasingly important over the next few years. So thanks very much to the APDC for organising this opportunity to help bring you all along on what we're trying to achieve there. At the moment, Defence doesn't do a lot of space training for its people from IET at any point really, unless you really go out and hunt for it. So I generally start these discussions with a quick 101 on space, where it is, what it is, and that sort of stuff. And to do that, I usually bring my trusty globe, highly scientific instrument, purchased off Amazon. And this gives you an idea. So the picture there is to scale, and the first orbit is LEO, and it says up to 20 kilometres. Now obviously objects don't orbit at 5 metres above the Earth or 20 kilometres. The typical rule for where space starts is 100 kilometres. It's a point called the Kármán line. It varies a little bit, but it's the point at which you have to travel so quickly to generate aerodynamic lift that you actually reach orbital speed anyway. So it's a physical crossover point. It varies with the atmosphere and that sort of stuff, but it's a rule of thumb we use. So LEO's about 100 kilometres to 2,000 kilometres. There are big benefits to LEO, okay? If you want to take photos of things, you want to be as close as possible, so you want to get high resolution, so you'll be nice and down low. You also don't need much power. The boss mentioned very small satellites. You can get very small, very low power satellites in this area that can still have an effect to and from Earth. You do have a small field of regard. So the International Space Station orbits at about 400 kilometres altitude, which is roughly Canberra to Sydney as the crow flies, which is, again on my instrument here, about the width of my thumb. That is how high the International Space Station orbits Earth. All right, it's actually quite close. But what that means is that I can't see much of the Earth from there. Okay, so it's got a very small field of regard. You don't have that huge access and low persistence. Satellites at that altitude orbit at about 90 minutes per orbit, and they'll be overhead and gone in 10 to 12 minutes. Okay, so they don't stick around. It also means you have to track them. So if you want to do anything really fancy with them, get a good lock, you actually need a dish that can track those. Or if you want to look at them and get a good hack on them, you've got to be able to track them. Next is medium Earth orbit, which goes from LEO at 2,000 kilometres out to GEO, which is geosynchronous Earth orbit, at 35,786 kilometres. Good example of something in GEO is GPS. You're getting low resolution because you're 20,000 kilometres away. Medium persistence, because your orbits at GPS altitude at least are about 12 hours, so you're passing overhead a lot more slowly. That also means that you can have a much smaller constellation. If you tried to put GPS at 2,000 kilometres, you'd have hundreds of satellites in the constellation. These guys get away with around 20. And you've got a larger field of regard, okay? You can see a lot more of the Earth. You can provide signal to a lot more of the Earth. And then finally, geosynchronous orbit, out at 35,786 kilometres. And at that altitude, you orbit the Earth at the same rate that the Earth rotates, okay? So if you're on the equator, you remain fixed above a certain point as the Earth goes around. You've got really low resolution at that altitude, and it takes a lot of power to get signals to and from, but you've got a really large field of regard, about 42% of the Earth's surface. Okay, and the reason it's 42% instead of 50% is you can imagine from way over here, you start to glance the Earth at about there, so you don't get that whole hemisphere. Okay, so you need 3 of those to provide whole of Earth coverage, almost whole of Earth coverage. Very persistent, like I said, they hang in the sky above a fixed point, and very little tracking required. They do move a bit. You can't get it's nature. You can't get perfection. And if you want to get a good lock, you need to be able to track them. But the average user can just set up their internet dish that you see on houses and set and forget. Okay, so that's the great thing about GEO. I mentioned that you don't get coverage of the whole Earth from GEO, so you don't get coverage of the poles. Okay, so SATCOM at the South Pole is no good, and at the North Pole it's no good. And countries like Canada and Russia have developed orbits which the Russians developed a Molniya orbit, which basically goes down around the southern poles quite quickly, but then has a lot of hang time as it goes up through its whole orbit up top. You need 2 or 3 of those to provide persistent coverage of those North Pole areas that the geosynchronous satellites can't get. That's space in a nutshell. If you want to know a lot more, do the Defence Space Overview course. Look out for the DEFgrams for that. It's about 3 days. If you want to know a lot more, do the Masters offered by University of New South Wales. So what is space? That build's not going real well. Space to a lot of people is just the big events, right? It's the shuttle, it's the moon landing. See what I did there? And it's small things like SATCOM to and from. It's like they've got a very basic understanding. To a lot of people, It's this sort of thing. And Star Wars is our greatest enemy when it comes to teaching people about space, because so much of what happens in Star Wars is garbage, except the Ewoks. Space's greatest trick is to hide itself. It hides the complexity really, really well. We use space every single day for so many things. I mean, everyone pretty much knows they're using space for this. You'd be surprised how many people don't realise that GPS supports their Fitbit or their other smartwatch, and Uber, okay? The complexity is hidden from us, so people just don't know that they're using it. These guys know they're using it. Precision agriculture, the mining industry doing remote operations and very precise operations, the efficiencies that these guys achieve by using space, reaps rewards on the order of billions of dollars per year. And everybody uses it for weather. Transport, maritime, air, all that sort of thing, all made far more efficient and approachable by space. And ATMs and things like our financial institutions, the T in positioning, navigation and timing, which is provided by GPS, is the forgotten element in PNT. Right? Everyone thinks it's for navigation, it's for getting around, so that people know, for us, for precision weapons, they know all about the locational aspects of it. But the timing aspect provides secure comms, ATMs, internet connections and all that sort of thing. Makes our emergency services more efficient. As I mentioned, everybody's got space in their hand. It supports internet timing, and without that we don't get YouTube and therefore cat videos. Imagine that. So, what is space in the generic at the architectural level though? There are generally accepted three segments: the space segment, the ground segment, and the user segment. The space segment is what you think it is, okay? It's the satellites that are out there from LEO right up to GEO doing their job. I've mentioned in the space segment there the subjects, okay? As you design a space system, what you are trying to do on Earth, whether it's communicate with Earth, observe something, influence something, whatever you're doing, you must consider your subject. So really the space segment extends all the way to what it's doing either towards the ground or what it's receiving from the ground. The ground segment is the section that controls the satellites, okay? You've got to keep them up there, you've got to maintain their batteries, you've got to maintain the system, you've got to get data to and from, make sure it's healthy, maintain its orbit. There's all these different functions under telemetry, tracking and control, just to keep the satellite where it's meant to be and doing what it's meant to do. The mission system can be either a part of what you're doing, or it can be, again, hidden. So at the second Space Warning Squadron, for example, we did the TT&C and we did the mission and we sent data out. So we did missile warning and space launch notification, and we sent the data out. The user was a customer, okay? Whereas with other systems, the user can be definitely part of the system. GPS is a great example of as well of where the complexity is hidden. They provide a set of standards to manufacturers of GPS chips around the world, and they take those and away they go and make whatever they want out of it. Okay, the employment of GPS and position, navigation and timing is only limited by the imagination. I'll talk a bit more about that later. But then you've got the user segment, and the user segment is super diverse. And I apologise if your thing isn't represented on the slide there. But you've got everything from fast-moving aircraft using communications to command and control signals to far more fast-moving tactical situations. You've got maritime getting all over the globe. Vehicles and personnel at all levels of size and shape and complexity trying to access space services, right down to Army and Air Force accommodation along the way. Sorry, those are meant to be a deployed headquarters and a Russell. All using space systems to get their job done. Down to the military context, and this is stolen from the US Department of Defense, Joint Pub 314, Space Operations. We get down to some very specific mission areas. And there are three different, broadly, three different types of mission. There's force enhancement. These are the things that we do to make the joint force better, smarter, more efficient, more lethal. And these, this here says we don't do space for space sake. Okay, you don't go to space if you don't need to. If you can do something with an aircraft or a ship or a person on the ground, do it with them. Okay, because these systems are quite complex. But a lot of things can be done better and smarter from space. And here are some examples of what they are. So satellite communications, we all know what they are, and you think point-to-point voice, point-to-point data, UAV command and control, all that sort of thing. All of these global type of operations, the things that enable us to be a global expeditionary force. Missile warning, using those overhead persistent infrared systems. I'll talk about those shortly. To provide warning both at the strategic level, so warnings of attacks against the homeland by great big missiles out of hostile nations, right down to theatre ballistic missiles and aircraft getting around the place. Anything that emits infrared, above certain thresholds, is provided to the Joint Force. Obviously a very urgent mission. Intelligence, surveillance and reconnaissance, both tactical and strategic, happens from space. Positioning, navigation and timing I mentioned. And finally, environmental monitoring, or weather. Okay, weather can be a deciding factor in battles. We've seen time and time again over the years, especially Middle East, great big sandstorms can be picked up from space and can be a go, no-go decision for many, many kinds of missions. And if they are a go without that information, you end up in the dirt, you'll be glad that you had that information up front. These days, we need to assure our access to space systems. Defensive space control is all of those things that we do to prevent an adversary from taking away our access to these critical systems. Okay, so it might be finding and destroying GPS jammers. It might be detecting their nefarious actions on orbit that we want to affect and taking actions to defend our satellites, any of those things. Offensive space control is us trying to deny an adversary that advantage. Okay, and all of these effects happen in all 5 domains. Okay, so you can use an aircraft to bomb a satellite ground station, and you are doing offensive space control if you're taking out an adversary system. Okay, so it doesn't, just because it's a space mission, doesn't mean it has to happen in the space domain. And in fact, in most cases it won't. One great big reason for that is the worst thing that anyone can do in space, Steve Henry's humble opinion, is to blow something up. Okay, the last thing you want is one satellite, whether it's alive or dead or yours or theirs or whatever, which is one piece of one object getting around at up to 8 kilometres per second, to become 1,000 objects getting around at 8 kilometres per second, okay? Because they're all weapons. They will all destroy anything in their path. So offensive space control, defensive space control, think effects that aren't going to cause debris. And finally, space situational awareness. In every single domain, we need situational awareness of what is going on in order to shape that domain and operate in it, and space is no different. All right, so what is Defence doing about it? This is from the 2016 IIP, and you can see that there's quite a range of things there. But the total is around, if you take the high numbers, it's 11.75 billion, and at the low end it's $8 billion. That's 5% of the IIP. We're spending 5% of the IIP on space. And as the boss mentioned, there aren't that many of us working on it. We've got a team, and I'll show you some shortly around the place. But you can see here, satellite imagery capability with AGO, SSA with us here at Air Force Headquarters, PNT with our colleagues at JCG, and satellite and terrestrial communications infrastructure, Collins-class submarine and maritime communications modernisation being managed by Navy over fairly extensive time periods in most cases. All right, and this is who's putting all of those, who are having an impact on all of that. So you can see over the far side here, and sorry, this is fairly high level. I'm not going down to one CCS operates SATCOM, and different units operate SATCOM, and everybody has to maintain their P&T. So forgive me for sort of keeping this very high level, and it's a mix of who's doing the operations and who's influencing the capability. So space awareness, here we are doing our space situational awareness and military missile warning capability today. C2 and operations support. So the Australian Space Operations Centre does day-to-day ops for DG Air and DG Air Command Ops, so a mix of operations and raise, train and sustain activities every single day from out of Bungendore. And one remote sensor unit down in Adelaide operates space situational awareness and missile warning capabilities, as well as OTHR. JCG looking after communications and P&T capabilities. VCDF through military strategic plans, looking after those future strategic plans, okay? It's, a lot of this is happening out in the future. It's happening now, but the value of space is being realised. The amount to which we rely upon space has been realised, and adversaries are absolutely looking for ways to influence that. Army looking after their share of ISR, EW and SATCOM capabilities. Navy SATCOM over here. AGO looking after GeoInt collection systems. Strategic Policy Division developing all the various policy and having external interactions. DST doing a large amount of work on getting our understanding up so that as we try and develop capabilities, we are supported by sound S&T. And finally, CIOG operating the Defence Network Operations Centre at HMAS Harman to provide all of the SATCOM that we need around the world. So What are they working on, all those people? They're not just sitting around watching Star Wars. These are some of the projects, and you see it's colour-coded. So I'll start with Space Situational Awareness. You can see here that different types of projects have capabilities at different levels. So either in the ground segment or in the space segment, and there are different elements on the ground segment of users and mission systems. So SSA, for example, we plan to have a variety of, and I'll go into a lot of detail about these, a variety of capabilities on the ground, including a mission system and space-based capabilities. Missile warning for us is just ground-based, okay? So we have an operations centre at one RSU at Edinburgh that operates in cooperation with the US, and we have ground stations that downlink through Australia as well. SATCOM is going to be the complete package, okay? So future SATCOM programs, and in fact even past ones, have looked after satellites, the ground segment, the user segment, and the operations, the TT&C. We haven't done TT&C before for SATCOM, okay? We've operated payloads, so you talk to the payload itself back and forth, communicate with this guy, don't communicate with that guy, but we've not operated a satellite before. But that's what our next generation of ADF SATCOM is looking to do, to own and operate satellites. You may have heard of the Wideband Global SATCOM project. Started with 6 satellites. It was a US program. They bought 5 of them. We bought the 6th. And it's a geosynchronous band of satellites to provide global SATCOM. By buying the 6th, which just happens to be located over the Pacific region, we bought 1/6 of the bandwidth of the entire network. Because where do we send our deployed forces? Into the Pacific? A little bit, but the bulk of them are around in the MEO at the moment, and we need to be able to communicate around there. So the most of our WGS value we get out of satellites that we don't even own under a shared arrangement. And on average, about 80% of defence SATCOM comes from commercial providers. Next is ISR, so AGO developing satellites, as you can see there in yellow, and an operation system, and they're going to operate the things from the ground. And finally, PNT. For us, for positioning, navigation and timing, we'll continue to rely on GPS for the foreseeable future. So we just have to worry about making sure that our users and our systems are secure and operated well and acquired well. I'm going to focus on SSA for the rest of the talk. I mean, it's only a short talk, and I couldn't cover all of those projects in depth. So I'll try to get to the brief that you were given, that was advertised, through the lens of SSA. So SSA could be argued to start with overhead persistent infrared sensors detecting the launch of a satellite. And it'll let you know, hey, this is the satellite, this is where it's going. Its rocket bodies will sort of fly through this area. Some of those bits will become debris. And it'll let you know that this launch has just put a satellite into LEO, MEO or GEO. It'll let you know roughly where it's going to be so that you can start engaging your ground sensors. Importantly, missile warning, space launches and missile launches, both hot, both going where they need to go. And clearly, while they're trying to blow up our SSA sensors over here in this case, we want to know what's going on with those missiles. So the missile warning system provides notification of a launch, where it's going, when it expects to arrive, so that we can provide warning to forces on the ground or do something about it. So space launch heads up, and next thing is that you're going to get your mission system here telling you, hey, we need to get onto this area with some form of sensor. So what we're going to acquire on the ground here is passive RF sensors, which literally passive radio frequency, just listen to what's going on in the environment. Active and passive radars. Active radar being the radar that you all know and love that sends a signal out and receives it back. Passive radar uses signals of opportunity in the environment, so it might be a TV or a radio signal that it uses that's already there, and it characterises and senses that way, so they are silent. And finally, active and passive optical sensors. Passive optical sensor is a telescope, basically, of various sizes depending on what you're trying to do. Active telescopes use a laser to illuminate the target. Great if you're trying to illuminate something that doesn't mind being illuminated, but some people don't like their satellites being illuminated, so you might want to use that capability judiciously. I've got there the trade that you make between different kinds of sensors. Not all radars are wide field, low resolution. Not all telescopes are narrow field and high resolution. But you're making a trade between those different capabilities as you develop this network, depending on what you want to see. Up in GEO, a lot of the strategic capabilities are the size of a bus. Down in LEO, some of the capabilities that can influence us are the size of a loaf of bread. Okay, and in between all of those, belting around at, like I said, about 8 kilometres per second, you've got debris. Things that can take out your satellite without even meaning it, that you need to keep track of as well. So why are we worried about these different areas? Obviously, like I said, you've got CubeSats. So here's one target type, just the little CubeSats. The companies, the high schools, the universities, whoever's putting up a CubeSat to do an experiment becomes something that can influence your systems. Imaging satellites, we want to know where ours are and keep them safe. We want to know where theirs are and be able to deny them the access that they might like. Sorry, I should have mentioned as well, while talking about sensors, space-based, both high and low, don't have to look through the atmosphere and can get nice and close to the target. Up at MEO, that's where our global navigation satellite systems are. So GNSS is the general term for systems like GPS, Chinese Beidou, the EU's Galileo system and Russian GLONASS, and there's several others that we need to protect and look after. And finally, up at GEO, those strategic systems, communications, OPIR, and how important they are, registers how important they are to look after. Finally, human spaceflight. If you believe the press, if you believe what's going on, humans are going to be tourists in space before too long. There's going to be more and more of us up there. We're going to the moon, we're going to Mars, we're going absolutely everywhere. As with all other domains, the safety of human life is generally one of the highest considerations. So we need to be able to look after that. So what are we looking for? We're not just looking for where the dots are now, okay? In space, you're in Keplerian space as opposed to here on Earth where you're in Newtonian space. The best example I can give of what that means is that humans evolved in the Newtonian space. The things I can move and run away from and chase are the things that I care about. So the tiger there is dangerous to me. The tiger 100 kilometres away, I don't care about. I probably don't even know about. Space is, or can be, the opposite, okay? If I'm in a geosynchronous circular orbit and there's a satellite 50 kilometres from me orbiting underneath my orbit, okay, it's actually not a concern. If there's a satellite 70,000 kilometres away on the other side of the planet, but in 12 hours it's going to cross my orbit and collide with me, that's the satellite I need to be concerned with, the one that's 70,000 kilometres away. So it's not just knowing where the dots are now. It's having a quality mission system that can not only coordinate all of these sensors, but pass forward, do that orbit determination, figure out where things are going to be next, okay? Also, we're worried about manoeuvres. What changes in the picture? Why is someone manoeuvring there? And if that satellite manoeuvres there, and this is my strategic communications satellite, how long is it going to take them to get there? What are they capable of doing when they get there? Do I need to worry? It's getting ahead of that decision curve. And finally, other events. So you've got manoeuvres, other events. If something blows up, why did it blow up? Was it just an old dead battery that just lost it and exploded? Was it a collision? Was it a nefarious act? Did someone target that satellite? So all of these things are things that we need to understand. And finally, I'll mention space weather. Okay, space weather has a massive impact on our space-based capabilities, especially as it ionises or leaves alone the ionosphere. As that gets charged up, it can have huge effects on your SATCOM. All of this will contribute to us being operational, sceptical users of space-based systems, so that instead of just bashing the SATCOM box on the side and wondering what's going on and calling the tech, when you're out on operations trying to do a job, you think, well, hang on, I know that the adversary has capabilities that can do this. I know that my system was working fine a second ago. I'm going to check out the technical side of it, but I'm also going to get in touch with the Intello or headquarters and say, hey, I've got something going on here, so that we can start responding to those situations faster. And that's what partly what these education events are about, is letting people know that your SATCOM, or all of your space-based systems, it's not a sanctuary anymore. Okay, space is a battlefield, and it will be used against us in future conflict. So onto the fix that I think were in the brief. Industry is first. The Defence White Paper in 2016 led to the 2018 Defence Industrial Capability Plan, and in the Defence Industrial Capability Plan we've got the Sovereign Industrial Capability Priorities. You can see at the top there definition of the industry FIC, but down the bottom, Sovereign Industrial Capability Priorities are capabilities that are critical to defence and must be developed or supported by Australian industry. Okay, and SSA is one of those. So under surveillance and intelligence, data collection, analysis, dissemination, and complex systems integration, space situational awareness is called out specifically as something that we need to be doing here in Australia. It's an important future capability for us to be able to do for ourselves. The 2016 Defence Industry Policy Statement, which came out at the same time as the White Paper, created the Centre for Defence Industry Capability, which created two mechanisms to interact with industry: the Defence Innovation Hub and the Next Generation Technologies Fund. They had the amounts of money that you see there, 640 and 730 million respectively. This is a fair bit of cash over 5 years for these guys to accept bids from industry of opportunities that they think exist to meet our industry policy statement and now industry capability plan. And there's a few examples there of companies that we're working with for SSA specifically who've got Defence Innovation Hub contracts. I think we're up around $13 million worth of contracts now for companies and universities. You can see Western Sydney University there, that are doing world-leading space situational awareness. They go out to conferences in the US. Obviously everybody thinks the US is the world leaders for SSA, and right now in terms of capability they probably are. But in emerging capability, in research and development of new systems, Australia is right up there with them. Neuromorphic vision systems are biologically inspired sensors that can see satellites in new and exciting ways. Innovore Technologies, an Australian company developing their satellites right down to the smallest components themselves using 3D printing and other techniques, developing small satellites for SSA specifically, and Sabre Astronautics with a mission system. So, and these guys are working with the US, they're briefing the US. Sabre participated recently in a training exercise over there. They're leading the world, they're doing great work for us, and we will continue to engage them. Okay, so one of our biggest industry engagement events is SpaceFest. SpaceFest was named over beers, but it sort of stuck. So we might have called it something, I don't know, more war-y. But yeah, it's SpaceFest now. It's an annual trial/demonstration. I say it's trial/demonstration. What we're planning is that every odd year, so this year was one of those, DST will design a full-up trial plan. They'll give sensors a target area, target satellites, all that sort of thing. They'll analyse their results and do all of that good S&T stuff that informs our capability decisions. But every other year, it might just be a demonstration where these companies get to come together and Defence contributes to building that community and building that industry between industry, universities, the Australian Space Agency, all of these other actors who need to get together to make this stuff work. It's had a massive impact already. We have, and it operated out at Woomera this year. You can tell from the red dirt there. But we went out there. We had mission system providers come out and work with the sensor guys to say, hey, what do you, how does your data get output? Where do you need it to be informed? Where do you need the other information to go? And how can I get it into my system and apply it for good, not evil? It's been a phenomenal event and very popular. Great opportunity for engagement and collaboration, and like I said, it's both sensors and mission systems. So the diagrams you can see there, those are two 12-inch telescopes on a trailer. A lot of it's very, very Australian in the way it's done. So telescopes pop out of that little shell there, do space situational awareness overnight, and away we go. And DST is achieving excellent results with those in cooperation with Western Sydney University. HF passive systems, so using HF signals in the environment, including from ATHR, to see what they can get from reflected signals. That's Silentium Defence's system, called the Alien Spiders. That's the passive RF system, so it just sits there as a network and picks up those signals in the environment, again getting great results. And finally, this is a system from Curtin University cooperating with Lockheed Martin called Fire Opal. Obviously you can see the power there because this thing's going to be remote. It's not necessarily going to be sitting beside a power station or a power line. Inside that box there that you can see on top of the tripod is a Nikon digital SLR camera. That's all it is. That thing sits there on auto and takes a 10-second exposure, thinks about it for 5 seconds and then takes another 10-second exposure. You get three of those in a triangle on about a 500-kilometre baseline, and all of a sudden you've got a very cheap and very capable space situational awareness system out in the middle of the Australian desert. So these companies and universities really are thinking outside the box and achieving excellent SSA capabilities for us. Okay, the Avalon Air and Space Show 2019. You won't have seen it on any of the brochures, but that's what it's really called. We had the first ever space park there in cooperation with Jericho. So Jericho had their huge experiences and massive numbers of students and participants through, and tacked onto the side out in the sun. You guys had the aircon, I think, sir. Is that right? Yeah. So, so there we were in our tents with University of New South Wales, Canberra, Silentium Defence, Innovore Technologies, Western Sydney University and DST, doing a demonstration for the public of what is being done right here in Australia today to support S&T. Thanks to the Jericho team for coming up with some absolutely exceptional PR gear as well. We're not capable of this sort of creativity, but that's what the back of our tent looked like, facing the flight line. It was about 20 metres long, I think. It was really quite impressive, and it enabled space to sort of hit the Avalon Air Show running, and that's a tradition that I hope will continue in 2021. Okay, FIC, personnel. So that's industry. I've covered industry and engagement, that sort of thing. I was going to cover two other fundamental inputs to capability. Personnel. I think, my humble opinion, the space is about the jointest capability. It's global, it's everywhere, everybody uses it to some degree, whether they know it or not, no matter where they are or what they're doing. We've got about 60 space positions in the Air Force right now, a bunch of operators at one RSU. We've got the AusSpock out there with about a dozen folks. We've got a few of us working here at Air Force headquarters, but that is increasing quite quickly. Army and Navy have positions as well, and I'll give a shout out to Army here because they're doing a really good job as they develop one of their capabilities of sharing positions. So they're trying to get bodies into the Australian Space Operations Centre, as is the Navy, and Army are also opening up excellent opportunities for us in some of their SATCOM capabilities. So really excellent collaboration going on there, and hats off for those guys leading the way on that. Mostly operators right now because we don't own and operate that many systems, and plenty of civilians in the mix as well, especially out at the Defence Network Operations Centre. It's mostly a civilian workforce out there. But we are absolutely bringing on other categories to help us do this stuff. Intellos and analysts, engineers and lawyers are all coming online. Some are online now, but new positions are opening up next year. And the boss mentioned there's 2 or 3 of us in the headquarters now. We're getting an engineer next year. We're getting a 50% of a lawyer that we'll share with the Australian Space Operations Centre. We're getting more operators out at Edinburgh just to try and keep up with this growing capability. Initial training is probably a key activity right now. We're doing what we can to get involved in initial employment training, PMET and familiarisations around the place. So we train the capability technology management course, so that the ACSC for engineers over the last couple of weeks. University of New South Wales has opened up subjects as part of their undergraduate programs, and they've opened up a master's degree as well, 2 master's degrees, one in engineering and one in operations, which until about the end of this year have looked exactly like 2 engineering degrees rebadged. But to their great credit, they've responded to our needs. And next year, the space operations course will include subjects like conflict and cooperation in space, human technology interfaces and that sort of stuff. So it really is becoming a very, very applicable course to a lot of our space operators as well. The bottom line there is we need a space-savvy joint force and a joint-savvy space force, okay? We don't do space for space's sake. We don't train up all these people to be massive nerds and do space stuff all the time, not to contribute back to joint force capability. That is the absolute point of all of this, is to make the joint force more effective, okay? And space is part of that joint force moving forward. The other thing here is collective training. We need to train like we fight. We don't know how to fight very well in a contested, degraded and operationally limited space environment at this stage. In future conflicts, GPS will absolutely be jammed, or they'll try to jam it. SATCOM will absolutely be messed with. Satellites will be, perhaps spun around or have other things put in front of them or anything like that. We don't know, okay? But we're getting there, and we need to figure out how those are going to impact our joint fight. And you may have heard the term day without space. Let's do a day without space. Let's, on Talisman Sabre or something like that, take away GPS for the day and see what the joint force does. To me, that's about as dumb as saying, let's just not let them use planes for the day. Okay, it doesn't work that way. We don't just pack up our ships or people or tanks or whatever when the going gets tough, okay? We take the fight, to an adversary. So a day without space, can that, okay? It's operating in a contested, degraded and operationally limited space environment. Space often ends up in the too hard basket at the moment. That's understandable because of the lack of experts that we have and the lack of trained and qualified operators. But that's changing as the AusSpock grows to contribute space to joint to AOC exercises and operations, that sort of thing. So we're getting there. But the big challenge also is to include all stakeholders. Space is the greatest team fight, right? So it's not just Air Force doing it by themselves, or Army or Navy, or any military, or any country, or any department, okay? There's government systems that come on board. The industry has to participate as well. I mentioned earlier that 80% of SATCOM may come from commercial providers. Well, how do they feel when we go to war? Are they going to switch off their access so that they don't get blown up? How do their insurers feel about all that sort of thing? We've walked these roads before, right, with merchant shipping and that sort of stuff. We just need to apply some of this thinking to space as well. All right, so that's all I've got for the defence capability development part of it, but I wouldn't be doing my job as a liaison officer if I didn't mention the Australian Space Agency quickly and get that message across as well. So for those who don't know, the agency kicked off in July last year, so it's just over a year old, and they started off with a budget of about $41 million over 5 years. Absolute peanuts, I'm sure you'll agree, in government terms. 15 of that was for international engagement and 26 was operating costs. Their budget now already is over $220 million, okay? They've been kicking goals with both feet. So they've got that budget, and one of the big things for that budget is the $150 million that the Prime Minister recently announced to cooperate with NASA. And my dad called me the day that they announced it and said, why are we giving $150 million to NASA? Because he's from rural Victoria. We need water, we need agriculture, we need all that sort of thing. I said, we're not giving $150 million to NASA. That $150 million goes to Australian industry to cooperate with NASA. Now, if you were going to the moon and you needed to mine water, because water is mined on the moon because it's all frozen, you've got to go find it, track it down, get it out, to bring that back to a source and to extract it and to process it and that sort of thing, one of the first groups that you are going to come to is the Australian mining industry, believe it or not. World leaders in remote operations, okay? So that $150 million is for our mining industry, our agricultural industry, all of these people who are experts in remote operations. Geoscience Australia might get some to help out with positioning, infrastructure and that sort of thing. That's $150 million that will go to Australian industry to put their stamp on the world map when it comes to space, for missions to the moon and Mars. The Australian space industry focus is on real life, okay? We focus on those 5 mission areas, 2 types of access assurance and space situational awareness. The Australian Space Agency's job is to focus on the real life impacts for Australians. They're not a mission-focused agency. NASA is a mission-focused agency. They launch rockets, they do stuff, okay? The Australian Space Agency is an industry-focused agency. Their job is entirely about opening doors and getting things going. So, they always start their presentations talking about the impacts that they have on things that are important to Australians, agriculture and farming, and mining that I mentioned earlier. GPS and the blue dot, the way that you use space in your lives every single day, the hidden blue dot. And finally, emergency services management. Take a look at the bushfires right now and imagine what you could do with highly accurate, highly responsive infrared systems that could map those fire fronts really accurately and quickly. So the purpose of the Australian Space Agency is to transform and grow a globally respected Australian space industry that lifts the broader economy, inspires and improves the lives of Australians, all underpinned by strong national and international engagement. Okay, so that's their headline. And this is how they're going to do it. So they released the Australian Civil Space Agency a month or 2 ago, I think. I'm pretty sure it was August. And here's what it does. It's got 4 pillars. Internationally, I want to open doors, okay, to NASA, to the European Space Agency, to the international space industry, to the Lockheed Martins and Boeings of the world, bringing them in to work with Australian companies. The national is to increase capability by opening those doors and mobilising Australian universities and industry to get those things done. We want to be a responsible space actor, regulation, risk and culture. So our belief in a global rules-based order extends to space, okay? We want to be responsible actors up there, we want to do the right thing, and to the extent possible, we want to help ensure that others are doing the same thing. So the Australian Space Agency is very, very active with the UN. And finally, inspire, build the future workforce, starting in the high schools and the universities and working up through the workforce to get people going. I should mention that the agency passed its first act 3 months after opening its doors, okay? And their process has been highly interactive with the industry. So they recently passed or put forward, I can see my badge reflecting on people's faces, I apologise for that, put forward the new Launches and Returns Act. So the Australian launch industry is growing very quickly. Two highly credible launch facility proposals are on the table. Equatorial Launch Australia out of Nullarbine in the Northern Territory and Southern Launch Australia out of the Eyre Peninsula in South Australia. For reasons I won't go into, they both provide access to different types of orbits and are both excellent locations for doing it. They sent that out, and I should mention, in cooperation with those launch facilities who just provide the place and the space to do it, there are actual rocket companies developing. Black Sky, Gilmore and others developing the rockets to get stuff there. They had huge input on all this and the agency was very responsive. So it was a really positive and interactive process. The agency is not made up of space experts. It's got 2 or 3, but it's made up of lawyers, it's made up of entrepreneurs, it's made up of government experts, and these are all of the things that we need to enable the space experts out in Australia. These are their 7 civil space priorities, and you'll note that the top 4 align very, very naturally with what we want, okay? We want good PNT. We want good Earth observation for intelligence, surveillance and reconnaissance, SATCOM and space situational awareness. The others are supportive and very useful, but you know the top 4 there are absolutely things we need. What I'll mention is the positioning, navigation and timing. Geoscience Australia, for the National Positioning Infrastructure Capability, received on the order of, and I'm going to lowball it here, I think it was about $200 million, but I think it's more over a set period, to develop national positioning infrastructure capability in Australia. Their goal is to improve GPS accuracy in Australia, which is about, you can count on 10 metres really, across the country. They want to improve it to 10 centimetres everywhere in Australia and 3 centimetres within Wi-Fi coverage. Okay, so that'll be done using a variety of technologies, both a space-based augmentation system, so extra satellites on orbit, and they'll be designed to be in different orbits to GPS for various reasons, but also the ground-based technologies, networks on the ground that assist your devices in using GPS. It's all about the downstream application. So having 10 centimetres or 3 centimetres might just be cool, but what about 3 centimetre GPS accuracy in Sydney? And the best example I've heard is what about for the vision impaired, okay? So you can't use GPS to get around if you're vision impaired right now because you don't know if you're on the footpath or in front of the truck, okay? 10 metre accuracy is not good enough for you to get around. But imagine 3 centimetre accuracy. You'll know which side of the concrete curb you're on, okay? So all of these downstream applications are improving the lives of Australians and just making life better and easier. Can you imagine your GPS actually working in the Sydney CBD? How cool would that be? That is all I've got. I've left about 14 minutes for questions, so got that. I don't own that. I wish I did. If anybody sees it on eBay, please do grab it. I'll pay you for it. That is it. If anybody has any questions, thank you.